Presentation. This is also from a heterojunction manufacturer, indeed a pioneer of heterojunction segment, which is Huasun. So Zhou, R&D Director of Solar Cells at Huasun, is going to talk on mass production status and future trend of heterojunction solar cells. So please,
Hello?
the floor
Can you hear
is
me?
yours. Yes.
Okay. Hello, everyone. I'm Zhou from Huasun. It's a pleasure here to show you what Huasun have done in 2022 and what about the future trend of the heterojunction solar cells and modules. First, I will show you a brief introduction of Huasun. Huasun was founded at July 2020, and we are a newcomer of solar cells and modules, which only focus on heterojunction solar cells and modules. Our headquarters are located in Xuancheng, Anhui Province, and our sales center in Nanjing, Jiangsu Province. We are now have more than 2,100 employees. And to the status now, we have more than 2.7 gigawatts both solar cell and solar module capacity, which contained in our phase 1 and phase 2 factory. In our phase 1 factory, we produced the M6 size cells and modules, and which is of almost 600 megawatt capacity. And in our phase 2 factory, we are produce G12 size cells and modules, which of 2 gigawatt of capacity. And those two kinds of products that we can also offer to the market now. In next, we will show some mass production data from our factories. Here is our trends of throughput and yield of our first cell factory, which means M6 size cells. You can see from we started the manufacture in 2021, quarter 2, and we spent several months to reach like 16.8 10,000 pieces of cells one day, and we reached the cell yield like more than 97% in several months ago. And you can see that the throughput was also improved in 2022, which is because the improvement of the process time and the control of the collaboration of different processes, which is quite important in the heterojunction cell production. Here is the throughput and yield of our M6 modules. As you can see, the yield is more than 99.6%, and the capacity is grown from the beginning of the 2022 to now, and now we have like 619 megawatt actually output of M6 with solar modules, and almost like 400 megawatts G12 size of modules. at this time. Here is our daily highest efficiency of our heterojunction 2.0, which means heterojunction 2.0. We named the heterojunction cells with both sides amorphous silicon as heterojunction 1.0. Heterojunction 2.0, which means the front side n-doped layer was changed from amorphous silicon to microcrystalline silicon. As you can see, the efficiency was increased about 0.5%. And we have got the best cell batch with average efficiency of 24.9. Here is our R&D data for the heterojunction 2.0, which also worked on the M6 size wafer. The best batch is about 25.5, and the best wafer, the champion wafer, was 25.6. And we got 500 watt module, which based on the M6 144 half cells, which means the module efficiency can reach to 23%. Later, I will show you some key point we think, which is people are very curious about. The first is the silver consumption. As you can see, from the 2018 to now, the silver consumption was reduced very quick, especially in this year, 2022. We started at 180 milligram per piece, which on the M6 wafer, to now about 100 milligram per piece. We cut off like 80 milligram per piece in this 1 year. And in the next year, our aim is to reduce the silver consumption to 70 milligram per piece by use the silver coated copper paste. And in the year of 2024, we think that plating may contribute to the silver consumption reduction. Converted to the silver consumption per watt, you can see now is about 15 milligram per watt now at the end of this year. And we will get like 10 milligram per watt at the end of the next year. Okay. Then we talk about thin wafer application. This is our result about the cell efficiency on different wafer thickness. As you can see that within the range of the wafer thickness between 100 micrometer to 140 micrometer, the cell efficiency does not change very much, which ensure that heterojunction solar cells can use that thin wafers without a lot of power loss. The reason why heterojunction makes such different behavior is because when you decrease the wafer thickness, the IC of cells goes down, but the voltage, the VOC, was increased because of the excellent surface passivation. Okay. It is the symmetric design, low efficiency loss, the fuel process, and the low process temperature, which can ensure the industrial goal of wafer thickness of heterojunction would be 19 to 100 micrometer. Okay. Talk about the cutting process. As you know, Huasun has also started a wafer cutting factory in Anhui Xuancheng, and which is used for demonstrating the improvement of cutting process. As several months of mass production, we are now think the equipment, material, and process of 113 and 120 is ready for mass production, and now we are mostly transfer from 130 to 120 now. And in the R&D line of cutting lab, the cutting yield of 100 micrometer thickness wafer has reached over 90%. That showed that the cutting process has a big potential to reach the same goal as we think in the cell and module process. Talk about our silver cost copper plate application. People are very concerned about the long degradation about the copper paste. We have done a long time test, pH test, which shows that the use of silver coated copper paste will not affect the long-term stability much. And now when we use the double-sided silver coat copper paste, there will be a efficiency decrease because of the front side paste was not fully optimized, and it will affect the IC and FF in the front side. So for now, Huasun has used the silver coat copper paste in the back side and only on the fingers. As you can see, this is our production results. The cell efficiency was almost the same. It's just 0.03 loss, which can be neglectable, and the wet weight was reduced a lot. As you can see, the normal silver paste has a total silver consumption of 126 milligram per wafer, and when we use the coated copper paste, it's about 100 silver consumption per wafer. It's almost 20 milligrams reduction. And in the future, in the next step, we will try the coated copper paste on the bus bar and the front fingers. In the last 1 year, we found that heterojunction cost can reduce very quickly. Here are our non-silicon BOM costs from January to September now. As you can see, the metal paste, screen, TCO target, and gas and chemical all shows a large amount of reduction, and the total degree of reduction was 53%. That's a very rapid reduced speed, and we think that the heterojunction will remain those fast speed of reduction in next 1 or 2 years. Talk about the future trend of heterojunction. For the cell structure, as we mentioned before, heterojunction 1.0, which contains double side of amorphous silicon, and in heterojunction 2.0, we changed the front side n-doped amorphous silicon to n-doped microcrystalline silicon, and in which was also started in our phase 2 factory now, which is ramping up stage. And in the next year, we will implement heterojunction 3.0, which means double side microcrystalline silicon from both front side and back side, which can give us about 0.5% efficiency gain. And in the year of 2024, we would like to use copper plating, show the copper plating and in front and back side to replace the silver paste or silver coated copper paste. The advantage of copper plating was not only the cost reduction, it can also bring us several efficiency gain, which like 0.3 to 0.5%, which is also very important in the heterojunction solar cells. And after the copper plating process, there are actually 2 dimensions. One dimension is for the fallback contact, and the other dimension is for the heterojunction and the perovskite tandem solar cells. And talk about the cost reduction ways. We divided them to several species. The first of all is efficiency. Here, efficiency gain not only from the cell part, from the HJT 1.0 to HJT 5.0, but also for the module part, which means some light convert film, light reflect film, and zero bus bar connections, I think. The second part is silver consumption. In the future, the zero bus bar and copper plating will decrease the silver consumption to ultimate 0, which means a huge benefit against the other silicon-based solar cells technology. And some improvement was need to be done about the manufacture, which about the yield and the uptime and the consumption of like water, electricity, etc. And the equipment part, now the price of the HJT solar cells is quite expensive, and we expect it to reduce to 250 million per gigawatt in next few years. And talk about the wafer part. We also implement 130 micrometers wafer in our production line now, and we are looking forward to use 100 micrometers in future, which the demonstration of cutting and using of cell and module was already being done. It's just need to transfer them from the demonstration to the mass production. And we we are using the gathering process to lower the silicon material cost, and we are using
sorry to
half-break.
interrupt you.
Yeah.
You might
Yeah.
have to wrap up in a minute.
Okay.
Yeah, thank you.
We are also developing half-break cutting, which can ensure the 100 micrometer wafer thickness. And about the TCO part, the lower indium and zero indium technology was looking for. Okay. The last page, I would like to show you the roadmap of Huasun. We begin at 2021 with the cell efficiency of 24.5, and now the efficiency is near 25.2, and at the end of 2025, we would like to induce the prototype tandem solar cells in the production line. So far, we are now on the schedule now. Okay, thank you for your attention.
Okay, thanks a lot.